So we have a gas loss problem because we see that there's a volume of gas at 99.0 kilopascals is 300.0 milliliters. And if the pressure is increased to 188,000 pascals and the temperature remains constant, which law and what's the new volume? So we know that we have some choices. It could be a gas law on the gas law triangle. It could be Dalton's. It could be Avogadro's. And it could be ideal. So when we look at this, what do we need to know? If it's on the gas law triangle, it is a single gas that has two stages, an initial and a final. So you would see two sets of numbers. Two pressures or two temperatures or two volumes. And then it would ask you to find the second pressure, volume, or temperature. If it's Dalton's, you're going to see pressures, okay, and partial pressures. It might ask you to find the partial pressures, or it might give you the partial pressures. The partial pressures are the pressures of individual gases. And you would see with Dalton's multiple gases. If it's Avogadro's, the moles and the volume are going to change. They're going to have two stages. Okay? Over here, PV over T, moles are constant. So if your moles aren't constant, then it's probably a good shot that you are not going to be using the gas law triangle. So check the other ones out. Are you dealing with partial pressures, or you're dealing with the relationship between moles and volume? And note Avogadro's could say grams, because you can use grams to convert to moles. So you could see grams in volume and it be an Avogadro. Avogadro can be a single or multiple gases. Ideal gas law is a single gas, okay, with single numbers, so no stages. It would have one pressure, one volume, one set of moles, or one set of grams, one set of temperatures. So right now we see kilopascals here, that's a pressure, so pressure 1, and this is a pressure, pressure 2. So we know it's not ideal because we have two stages. Okay? We also know that we're talking about volume, and we want to find the new volume. Okay? So it's not Dalton's, because Dalton's is dealing with moles and pressure, or grams and pressure, not volumes. Avogadro's, well, Avogadro's is moles and volume. Okay? But here we know that we do have volume changing, but we don't have any moles or grams. So we have no relationship, so it's not Avogadro's. So that leaves us with one of the laws on the gas law triangle. Temperature is constant. Constant temperatures get X'd. We have a changing pressure, and we have two volumes. Okay? So this means that it is Boyle's law. Pressure 1 times volume 1 equals pressure 2 times volume 2. Oh, let's figure out what these are. Pressure 1, okay, so this is our givens, is 99.0 kilopascals. Pressure 2, 188,000 pascals. Temperature is constant, so I don't need to write it down. So even if it said temperature of the first stage was 25 and then held constant, that would still say that I would X out temperature. That does not make it combined unless the temperature at the top and the temperature at the bottom changes, along with the pressure and volume changes. Okay, I have a volume. That's my first volume. V1 is equal to 300.0 milliliters. What's my unknown? What's my new volume? V2 equals question mark. It didn't give me a set of units, so I'm going to assume that I can just keep it in milliliters. I have my Boyle's law there, P1 V1 equals P2 V2. Substitute solve sig figs is next. P1, 99.0 kilopascals. Volume 1, 300.0 milliliters equals pressure 2. Oh wait, that's in pascals. I need to have these guys match. Kilopascals to pascals. There are 1,000 pascals and 1 kilopascal. Okay, so when I plug that into my calculator, it's 188 kilopascals with a volume of 2. Multiply these together and divide by 188. Gives me 99 times 300 divided by 188. 157.9787. What are my units for volume? Milliliters equals volume 2. I substituted, I solved, and now I have sig figs. 3 sig figs, 4 sig figs, 3 sig figs. So my answer can only be 3 sig figs. The 9 tells me I'm going to round up my 3 sig figs to 158 milliliters.